Hi, thanks very much. Yep, I'm Rae. I'm going to be talking about locales and writing systems and what that means for you. And, okay. Sorry? No. Okay, so firstly, a quick little bit about me. That's obviously a picture of me. It seemed like the thing to do, but you can see my face, it's right here, so never mind. I am a PHP and Python developer from Zurich. I work at a company called Leap, and mostly at the moment I'm doing Symfony, but I also do Django and CCAN stuff. That's my Twitter handle right there, and my pronoun is they, in case you want to tweet about me using a pronoun, that's the one to use. And probably the most important bit of information on this slide is the flags at the bottom. English is my first language, I speak pretty good German, and I speak a little bit of Spanish and Swedish, I'm learning. I don't speak actually any of the languages I'm going to be talking about in this presentation. So if I make a mistake, that's totally on me, and I'm sure someone can correct me at the end maybe, or just tweet at me and tell me I got it wrong. You might wonder, okay, we don't actually have to worry about this stuff. We're in Python 3 now. Everyone's using Python 3, right? We're all using Python 3. And Python 3 has Unicode by default, which is amazing. You no longer have strings, which are byte strings, and then Unicode strings, which you have to remember to mark off with a U before you put them in, and probably, if you're like me, always forget it somewhere. You have to worry a lot less about encode and decode, which one is which. Is it UTF-8? Is it something else? I didn't put the coding at the top of my, the encoding at the top of my code. If you want to use a different encoding than UTF-8, then you can still specify that, but it's just kind of assumed now in Python 3. Your source files will be UTF-8. And you see a lot less of this. My first ever programming job was mostly text parsing and editing for a company in Zurich. So where I was first like, hey, everything's ASCII, oh wait, no. The name of the city had normout in it. Things were difficult. But although we live in this Python 3 utopia, there are still difficulties, because writing languages has been going on for thousands of years, and people have just figured out all manner of really cool and interesting but weird ways of doing it, which aren't always reflected well in either the Unicode standards or our programming languages. Why does this matter? I don't want to say that this is the most dangerous mistake in this whole presentation, but it is the only one I know that has got people killed because of it. The faces you're seeing up here are Ramazan Chalchaban and his ex-wife, Emin Chalchaban, and a few years ago, they were getting divorced. They had an argument via text message, and the message that he sent to her did not use the Turkish character .i, because his phone's operating system didn't contain it. Unfortunately, this meant that the message he sent to her, which was supposed to be, you know, kind of nasty, they were getting a divorce, but relative to the argument at hand, actually turned out to be something quite obscene. She showed her family, everyone got in a huge fight, and both of these people are now dead because of localization issues. Yeah, I've put a link there, so if you want to go and read the whole kind of sordid tale, then you can do that. Okay, how can we avoid this? Because this is obviously something to avoid. The problem you see is here. Turkish actually has 4 letter I's. Unlike most other languages that use Roman letters, Turkish actually has a dotless I, and the capital dotless I is what looks like our regular capital I. And it has dotted I, which looks like our normal small I, and then it has a capital dotted I that goes along with that. And just as a note, I've put quite a lot of links in this presentation because people have been writing some really good stuff about this, and I just wanted to share my sources. And I have to say, it's kind of horrible that even in Python 3, Python does not handle this well. This is me trying it out. Import locale. I've set my locale to Turkish, and I have an array here of Turkish letters. So dotless ones first, I and capital I, and then dotted ones, I and capital dotted I. That looks great. But if I uppercase them all, you can see that, okay, dotless I goes to dotless I. The second one was already capital. And then it's just uppercased my dotted I to a dotless I, which is not correct. And then I tried to make them all go lower, and you can see I should have 2 dotted and 2 dotless I's here, and I have 3 dotted I's. This is really just a mess. It's got better and worse in different versions of Python. While I was researching for this presentation, I've seen a lot of error reporting and bug reporting threads. And really, this mistake as it currently stands has gone through all kinds of iterations of different mistakes, which is grand. And I have to say, I've really only found 2 solutions for this, and I don't like either of them very much. There is a library called PyICU that's a wrapper around the IBM International Components for Unicode C++ library. And if you install that and build it and then import the library from it into your code, then you can use its methods and it will just work. Turkish and loads of other languages, I guess all of them, go up and down the cases perfectly well. But the problem is really it's a huge library. It's kind of inconvenient to just use that every day for your scripts or something. If you're building a big system, then I would say definitely go for it, install that. But if it really bothers you and you don't want to go to that trouble, then you can make a translation dictionary. And whenever you uppercase and lowercase your Turkish language, you can just call that and translate it. I'm not really happy about either of these solutions, but there's kind of a big one and a small one for your needs. Okay, so that's it for Turkish. The next thing on our whistle-stop tour of writing systems is right to left. And obviously you all know, lots of languages like English write on the page left to right. And lots of other languages like Arabic, Hebrew, Farsi, Urdu write right to left. So here's an example which I like because you can kind of see both systems on a single sign. That's a street sign in Jerusalem, I think, somewhere in Israel. And of course, Unicode has a standard for this. Unicode has an algorithm for this. People are taking attention to this. And Python doesn't have built-in ways of handling it, but because it's Python, it's open source, and open source is great. We have libraries to handle this, including this one. I've been saying BIDI for bidirectional. I actually don't know if that's how people generally pronounce it. But we have Python BIDI for bidirectional support, which is, yes, we really do need a whole library for this, and it does need to be bidirectional support, because the interesting wrinkle, which is going to come up again in a little bit, is that Unicode wants your characters entered logically, not visually. So if I'm writing a letter in Hebrew, say, I'm not going to put everything in backwards, just so it comes out right to left on the page. And then say I'm writing an email in Hebrew and I want to include a URL which is in English or Roman characters. I'm just going to enter that HTTP, so on. And that will have to be printed left to right. That's cool. We install BIDI, and we just use it like this. Here is a Hebrew string. This means the Academy of the Hebrew Language, I think. We type it in, and it comes out what looks to us, left to right people, as backwards. And if we get a display for it, bam, it's now completely legible to a Hebrew speaker. Arabic, of course, needs the same kind of treatment. It just has one extra wrinkle, which is right to left is not always equal. Arabic letters take a different form depending on what position they are in the word. And this is where I'm kind of looking nervously into the audience because I know Bashar is here and he's giving a keynote this weekend on Arabization of things on the internet and computers. So this is like a teaser for his talk. It's going to be great. But you can just see, this is just a screen cap from Wikipedia. Right at the left here, we have kind of general standard letters. And you can see, depending on whether they're on the end, middle, or beginning of a word, they take different forms. And that means that if you just naively bidirectionalize some Arabic text, you get what looks like the middle picture here, and to an Arabic reader, that's ugly. And probably, I'm not certain, because again, I don't speak this language, but I'm sure it's hard to read as well. And again, hooray for open source. I found this awesome library, which was a port from an Android library, I think, Python Arabic reshapeer, which will just take the middle picture and give you out the bottom picture, which, I mean, even for someone who doesn't speak the language, I think that looks a lot nicer. And this text means, according to Google Translate, Arabic fantastic. Okay, we're moving on into, pretty much further into East Asia, I guess. Full width and half width characters. Do you notice any difference between the two rows of text here? I guess you do. One is much wider. And you probably definitely notice a difference here in the two lines of text. This is the same text. I just changed the font to Korea and realized, hey, Korea doesn't even try to do anything with that middle row. It just returns, I guess, the operating system default for these characters. Because they are different characters. They're in a completely different area of the Unicode table. These are full width characters, and the others are half width. And that's really not relevant to people who spend their whole lives in Roman character languages. But it is really useful for people in East Asia, speaking East Asian languages. And just to show you that they're used, the Han characters at the top here are probably not those exact ones, but characters like those are used in Chinese, Japanese, and in Korean, and they're always full width. And the ones down here at the bottom, hiragana, they're only used in Japanese, and they're always full width. But kana, which are also Japanese, can be used half width or full width. Interestingly, the half width kana are a really modern invention. They kind of got put into usage when people started making digital displays, because it's so much easier to display these half width characters than the full width characters beneath them. And so, yeah, obviously, we need digital displays, we need to send email. Let's just kind of squish everything into a box that will fit. Bam, done, it's a good one. The reverse is why we need the Roman full width characters. This is just a piece of text actually from a W3 doc about layouting Japanese text. And you can see that we have full width Roman characters mingled in these full width Japanese characters. And it just looks neater. It lets everything sit in a grid. It kind of doesn't like bump up against your eyes so much. Okay, obviously, if we're localizing text in like Japan or China, we need to be aware of this. At the very least, you need to be aware so that when someone says, hey, your website, none of the fonts are showing up. I just get these weird round, wide letters. You need to know, oh, hey, my Chinese or Japanese user obviously used full width Roman characters. And I can convert those because open source, there is this awesome library, JAConv. Again, I had a look. This is the best one that I found that does this. And I have a really quick example just to show you that you import it, you pip install it, and then you import it. And then you can do full width to half width characters. So these are all kana. And you can also take half width ones and make them full width. This library also transforms in between hiragana, katakana, and you can do special things with Roman characters if you need to. So yeah, I would recommend using that one. Oh yeah, I even have an example here. And this is great because you can see my full width Roman characters string has this \U3000 in it, and that's a full width space. It even has an extra space. Okay, this is the last actual language I'm going to take you to, and it's still in East Asia. This is my favorite language system. This is my favorite alphabet. I just think this is so cool. We are going to talk about Korean text. And here's a link. This is an awesome link. It will tell you everything, and then you can go and read more about it, because you also will think it's great. Basically, the Korean alphabet is more a syllabary. Each Korean letter, we have, well, okay, I'm going to call them letters. We have two characters here. One says Han and one says Gul, and that is the, Hangul is the Korean word for Korean characters. We have two characters, each made up of 3 characters, and each of these sets of 3 makes one syllable. So the yellow ones are the leading jamo. Jamo is the word for the little characters. The blue ones are the middle ones, that's always a vowel. And then the green ones at the bottom are the ending ones, the trailing ones. But yeah, this is really cool because it's a system that got developed in, I think, the 14th or 15th century by the court of the king at that time. And one day the king just kind of sat up and said, everyone is using this old-fashioned handwriting. We need a new scientific alphabet. And his courtiers were like, okay, we'll get right on that. And they made this. I love it. Okay, so, right. We talked a little bit already about, in the Arabic section, about combining characters, just so that you could see that, you know, the characters get combined and their form changes depending on where they are in the word. And something similar happens with the Korean characters. Each legal set of 3 jamo has its own little arrangement. They're not always horizontal or vertical. And all of these are coded into Unicode. And here we get to touch on something quite neat called Unicode canonical equivalence, which means if I have these 3 jamo together in one character, that's a syllable for Han, it means the same as the 3 next to each other. You wouldn't write it that way because it's kind of not going with the spirit of it, but you could, and then someone would still be able to read it. And I had actually some trouble making this slide because every time I tried to paste in the 3 separate characters, my wonderful browser would say, oh, you mean Han, and put it together for me, which was like, great, thanks for that, but not what I was going for. And so this means that any character in Unicode, like not just the Korean ones, anything, will have 2 normal forms. Actually 4, that's the next slide. One is normal form D, which means decomposed, canonically decomposed, as you can see, and one is normal form C, canonically composed. And just, this is a side thing because it doesn't actually bear on what I'm trying to tell you, but still, there's also Unicode compatibility equivalence. And that means basically backwards compatibility. There are identical characters at different points in the Unicode tables, and they have to be still like that because Unicode subsumed a bunch of older encodings. So, like, the Roman numeral for 1, we all know is the same as a capital I, but we have 2 code points for it. And that gives us compatibility normalization, which I won't touch on here. Okay, so I have my Korean string. This is Hangul again. And Unicode data, which is a built-in library in Python, no imports needed, will know how to normalize that in a decomposed way. So I just take my characters and I decompose them into JAML. Awesome. And yeah, again, Unicode normalization can normalize these characters in a composed way. So bing, they go into their little blocks, and that's great. So given this, what do you think will happen if I try to normalize the whole string, not just one character at a time? You would think, like in a decomposed fashion, you would probably think I'd get like string 1 for the first character, 3 JAML, and then another 3 JAML for the second character. Here we go. That is some kind of weird overlapping mishmash of both of them. I think, like, this is my terminal. I think it starts to print the first string of 3, and it's like, okay, I printed one character because it's, equivalent to the block. So I'll skip over one character along, and then I'll print the other one. And this is a mess. I don't know if we have any Korean speakers here, but I'm sure you're thinking that's a mess. The weird thing is, well, weird, good actually, is that Python can still handle this. It's just my terminal that was having a problem. When I printed this to a file, I got exactly what we would have expected to see. So the lesson here is, quite often Python does know what it's doing, but you're dealing with so many other parts of your system, like your operating system, your browser maybe. If you're doing an app, then you have a whole other system of things, and they might not be on the same page. Okay, just last, I know I don't have much time, and I'm not going to spend much time on this, seriously. Obviously, all of this localization stuff can give you problems with security, and that's a huge topic that needs a lot more time than I have in this talk, so I just deliberately didn't really go there. I'm just going to show you a couple of quick examples. I might not even really go through them before the end of the talk. One of them is databases dealing with sanitized input text from users. So you all know the user types, I don't like raisins, and they have an apostrophe. And because that could be considered like an end of string character, your database managing will just stick in a backslash there. And the hex encoding of that backslash is 0x5c. Now, say there was a character, and here's a spoiler, there are loads of characters, totally valid Unicode, that encode in more than 1 byte. And so like this one, I actually don't know what this character means, I'm sorry, I didn't write it down. But it's pretty far up in the Unicode list of characters. We need to use 2 bytes to encode it. And the second one is, 0x5c. So if your user can find a way to input the first byte of that, and this is not very well represented because coming up with a way that they would do that is, was not really in the scope of my preparation for this talk. If they can get that in, and then put an apostrophe, and then put some terrible stuff that your database will interpret and destroy everything, or reveal lots of stuff, then when you nicely sanitize that apostrophe, you have OXB8, then a hash, OX5C. Oh, that's this awesome character. Okay, we know that. And then what? Or 1 equals 1, I'll just put that into the database. And then it's a whole mess of pain. Most of the time, you actually don't need to worry about this if you're using proper protocols, but it's definitely something to be aware of. And then my last example for this talk, I know I have like 1 minute left. This actually came up about 2 months ago when I was reading around for this talk, and I got super excited. No one could understand why I was so happy about URL spoofing. Here's the list, the link to the blog post, I think from the person who discovered this. And I've used their examples because it's now been fixed and I couldn't reproduce it. That's good. Basically, say I have this Google link, and it's a link on my site, and you click it with your browser. What you might not see, in this case, yeah, you would see it. At the end, we have a bunch of Arabic text, and Arabic is a right-to-left language. So your browser will then just flip the whole thing round. Right to left, we go right to left, ignoring the whole Unicode. Well, okay, not exactly ignoring, but kind of taking lightly the Unicode standards for this. And this sends us to some Arabic with, as the server, with google.com as, a string in the rest of the URL. And that could be anything. Hooray! So here you go. I've given you at least 2 reasons why this stuff is really important to know about. You could die, and also you could get hacked. And yeah, just my conclusions wrapping up. I hope you agree that this is really interesting stuff. And I hope you also see that you won't be the first person to have problems with this. If you do, and there will be a library. And also, Python 3 is your best friend. And it's made these things so much easier for you. Thank you very much.